Hello everyone. Our project is quantifying forest and above-ground biomass dynamics in Lao PDR using GEDI and Landsat. We have three objectives. The first one is to construct a random forest classifier using forest structural matrix from GEDI and spectral information from Landsat. Secondly is to obtain historical AGBD, and lastly to realize AGBD changes and distribution. So the data we used here includes Landsat 5 and 8 for land cover and forest type classification, and GEDI for estimates of AGBD, and SRTM for elevation and slope, and GFCC and ESA dataset for tree cover. Coming to methods, in the very first beginning, we import Google Earth Engine tools and initialize a map with loss boundary. Here we load SRTM to obtain elevation and slope data. Next, we prepare for the classifier, including the forest masking, calculating spectral indices, creating composite images of all bands we obtained before, and training and validation, and performing random forest regression. This is all about how we can use GEDI and Landsat 8 data in 2020 to construct a random forest classifier. Then we just need to input the composite image for each year, and we can get the predicted biomass. Finally, we calculate RMSE for this model. These figures shows the random forest regression estimates for above-ground biomass density for 2001, 2005, 2010, 2015, and 2020. So let's take 2020 as an example. As shown in the color bar, the change from light to dark green represents the amount of biomass with a minimum value of 28 megagrams per hectare and a maximum value of 309 megagrams per hectare. The overall sum of AGB for each selected year is also calculated. We can see that AGB stocks in loss have shown a decreasing trend, particularly from 2001 to 2005. But as shown in the last figure, the variation of AGBD still has been heterogeneous and depends on site characteristics. So this is a model variable importance for 2020 estimate. Except for map, all input variables seem to be important to the model. Among them, the TCG and TCW, which stands for the Tessel Cap Index of Greenness and Wetness, are the two most relevant variables associated with AGB. So in terms of accuracy, the model has a reasonably robust fit, showing a nonlinear correlation, particularly in the lower biomass intervals. However, the performance of the model degraded when the model was validated with the validation data. So it indicates the ability of this model to generalize independent data is limited. So that's all for our presentation. Thanks for listening.